Hello, friends. Uh, last in the last class, we have already discussed till velocity. So our next topic would be the acceleration. What is an acceleration? What is its expression? And how it is related to velocity is very important. This is the uh, remains the main point of topic, that how acceleration is related to velocity. So in next few minutes we will look at this, how what is acceleration, how it is related to velocity. And let's go to our board. So we are going to our board. Before that, we have to switch on the lights. Where are the lights? And another light, and yes, this is improved. This is our last class, Maxwell equation, discussion of velocity. What is velocity? That I already told you in the last class. Sorry guys, there was some noise out there. Different kind of noise because this is too busy area. So let's do our today's job to explain you what is an acceleration. So the video, it becomes 3 and velocity becomes acceleration. Acceleration, rate of change in position was the velocity, but here the position replaced by velocity. So acceleration is rate of change in velocity. The velocity, in last class we have already discussed that it is rate of change in position. So how the rest of the formula would alter? Suppose we, instead of have initial position, we have initial velocity v1 and final velocity v2 at time t1 and t2. So the acceleration becomes change in velocity upon change in time, and the unit becomes second minus 2 or 2. If you explain in terms of delta, the acceleration is the rate of change in velocity, time remains time, minus 1 becomes minus 2, delta same. And suppose velocity, in the next in formula we can write it in differential form, a v, so minus 2. Rest of thing remains same. As far as formula is concerned, as I explained you in the last video, that how what is mean by differentiation of position with respect to time, it will give you the velocity, and I explain you with this formula, x is equal to 4t square plus 1. Suppose the velocity is provided in such a way, and the unit in that case become meter minus 1. So the velocity is different at different instant of time. At t is equals to 1 second, t is equal to 0 second, the velocity becomes 1 meter per second, and at t is equal to 1 second it becomes 5 meter per second, and so on. And the formula and the vector form formula for acceleration that I have done with for velocity from displacement. So this time I directly write in a vector form. Acceleration is also a vector quantity. In a vector form, its component along x-axis, same as the previous class, and the acceleration along y-axis is given by this. This is the vector in a orthogonal form. Orthogonal form means in a coordinate plane, the component along x-axis and component along y-axis of acceleration is represented in this way. This is called orthogonal form. So this is acceleration. Now the discussion on acceleration remains. What is an acceleration? Acceleration is a rate of change in velocity, nothing more than that. And there are some things which would discuss in like later class when we uh, discussed about force in law of motion. Before that we have to complete equation of kinematics, where this equation comes from. But before that, the initial thing about acceleration is just that it is the velocity. Let's discuss some concept related to force with the acceleration. For that we need to rub this Maxwell equation 3. So what? Acceleration simply is also equal to force experience by unit mass. The force experienced by unit mass is also called acceleration. These are same things. This is derived from the Newton's second law, which state that force on a body which has mass m and acceleration a. From here I can say that acceleration is equal to force per unit mass. So acceleration have another derived unit, Newton per meter. Okay, so this is the acceleration. Newton per kilogram. Okay, this is so acceleration, you should remember the acceleration as the rate of change in velocity with respect to time is the acceleration, or moreover from Newton's law it is also the force experienced by unit mass. This is the acceleration. What is the direction of acceleration? The direction of acceleration in general, in experiences, if suppose a vehicle moving with constant velocity or uniform velocity, then this vehicle or this car does not experience any difference. What I mean by this, at rest and at uniform straight line motion feels same. You would experience in a uniform straight line motion as you are feeling at rest. But whenever the force is not constant, means force is not constant, then you feel slightly different. You feel that whether you are experiencing a push in the direction in which you are moving, or a kind of resistance in opposite direction in which you are moving. So you can feel something is pulling you in the direction of velocity, or you would feel something pushing you opposite to the direction of velocity. So in these situations we feel this we called force or acceleration. If you talking the gross value, that is force, or you are talking with the force experience per unit mass, it depends, you say it force or acceleration. So this is acceleration, how the direction we generally feel. The direction of acceleration is either in the direction of velocity or opposite to the velocity. In this case the velocity increases, and this case velocity decreases. Try to feel whenever you are in such situation when velocity is suddenly increasing or velocity is suddenly decreasing, how what kind of feel you get at these situations. There are numerous daily experiences in which we can feel these things. One of the situation is when you are in a elevator, or if you are going up in the direction, then you would feel a force pushing you upward direction. You feel something when lift just started, when it start to moving in a uniform velocity, then it becomes normal. But whenever the lift starts and start going upward, you feel something. That feel, in terms of feeling, this is the force of feeling, a feeling of force or acceleration. Or similarly, when elevator going downward direction and just started to downward direction, you would face or you would experience a force in downward direction. Or there are other things. Suppose you have a experience, when you are sitting in a metro or it just stops at some station, you would feel something pushing you in the direction in which train was moving. And when it starts, you would feel that you are pushing in backward direction relative to the velocity in which train is just starting to move. So these are experiences. You can experience these concepts or these things in a many ways. I'm just giving you 2 examples. I think I should end here. I don't want to make this video too long. Especially I think I keep the length of the video in under 15 minutes because uh, after few classes, class may take some time. uh, I limited to experience just a one topic per video, so this completes in a some in a little time. But in later classes, when we relate these things with each other, and then it would take some time. So stop it and close it this. So this is the third video of the series. I want to make this course on YouTube. This is the very long journey, so I need supports of students who wanted to learn freely uh, at the comfort of their homes. So please uh, help us to grow this channel so I can complete this series, foundation series on this channel. So anything that you can do in terms of this digital platform, that is like or a comment or a subscribe. What I want or love to see is the comments that reflects that someone saw the video and have an interest in physics and want to discuss something specific, something. So these things are most welcome from me, and anything else you can do or add to that would be so grateful from me. So did you understand or not? Please comment about that. If you like, then like it. Like, also save important video in a playlist, which is helpful when you are referring in a future, and share it if it is related to or it can help to somebody. So bye, and just please subscribe this channel, because the criteria to grow the channel would also be the subscribers. So please subscribe. So bye. I would meet you in the next video, in which we relate these three things which we already study in our three classes, that is position, velocity and acceleration. That would be the equation of kinematics. uh, let's see let's meet in the next class. Bye.